asked if the disk is moving with a velocity at a point O. So this velocity has been given from point O. So the question is, and the velocity is given as 15 feet per second, and omega, which is 2 radians per second. You have to find out the velocity of A. So if this moves to the right, the body will move opposite to the velocity which is left, so V and X. So I'm going to use this reference planes I and J. It's good. And I will use the velocity formula for rigid bodies motion. So let's use this like VO equals to VA plus VO from A. And VO from A is nothing but omega cross R. So if I write down omega, since it is clockwise, when omega is clockwise, so I can write down omega like this. Omega is magnitude, clockwise is negative k unit vector. Clockwise means inside the paper, and counterclockwise means the direction of the velocity vector is outside the paper, perpendicular to the plane. And R O from A. So O so it is parallel to this J unit vector, so directing towards O from position A, which is perpendicular to that plate. So can I write down like what is the, it is 2J. Can I write down like 2J? Yes. Now let's do this multiplication. Now VO with respect to A can be written in terms of omega, which is this form, cross with R, which is 2 times J unit vector. And when you have the cross product of 2 unit vectors, this is very good way for keeping the consistency. If you have a clockwise rotation, then I cross with J, you will get K and cross, and similarly. But if you go opposite to K cross J means you are getting like opposite, you're moving opposite to the clockwise direction, which is negative, so it is negative I. You see my point? So negative I, you get negative I, but over here negative, there is already a negative sign with K, so negative I will be negative, multiply with this negative K, you so this negative outside, so you will get 4I. You will get 4I. Correct? Now what is VA? So VA in the vectorial form, if you take a look, this is my velocity on the left hand side, so it is parallel to I axis. There is no vertical component, and I can write down negative VA I in the vector form. We still have to find out VA. Agreed? And now what is V of point A, or the center of A? This is going towards the right side, and I can write down 15, which is magnitude, and the direction is I. Now let's write down everything in the equation number 1. So I'm going to rewrite the equation VO equals to VA plus omega cross R, and we already found the value from omega cross R. So this, let's write down here, it's 4I and this is minus VAI, and this is 15I. Now we don't have any J component, so we are in a good shape. Like I would say we just cancel I, and it's just one equation, one unknown, which is VA. One equation, one unknown, so I can just subtract and simplify. Negative VA equals to 15 minus 4, 11 meters per second, feet per second, I believe. And it's negative. VA is negative 11. The next question says, so the right answer is D. The next question states if the velocity of point A is 0. So imagine this velocity, this block is not moving at all. So what will happen? So let me draw here. So this is the block, and this is the wheel on the block, and this is point A. This is VO. This is VA. In this case, this is question number 2. In this case, VA is 0. So now the next question is asking you, if that is the case, what is the omega of this spinning wheel? What is that omega? So I will use the same formula. So VO vector equals to VA vector plus omega cross R, which is 2J. Now in this case, this is 0. VO, it is already given in the previous question, which is 15I. So I'm going to write down 15I equals to 0. We already calculated that K times J is equal to negative I, and negative I with this negative will be positive, so it will be 2 omega I. Do you agree with your professor? And then if you just eliminate I, because there is no J component, so we are good. And omega is just a cross multiplication, 15 over 2. 7.5 radians per second. So this is the correct answer.